With the increase in data transmission and exchange between multiple network devices for information purposes, the probability of an error or damage occurring to the original data bit is highly possible. To overcome this situation, we use certain networking techniques to detect and correct the damage to the data, one of which we will be discussing in today's session. Hi guys, and welcome to yet another interesting video by Simplilearn. But before we begin, if you love watching tech videos, subscribe to our channel and hit the bell icon to never miss an update from us. Now without further ado, let's take a look at the agenda for today's session. To begin with, we will look into what is Hamming code. Then we will look into terms related to the Hamming code. And in the end, we will look at a working example of Hamming code. Let's begin. The Hamming code method is a network technique that is designed to detect errors and corrects data bits which are transmitted during data exchange. It was first implemented by R.W. Hamming, hence the name Hamming code. This network technique is implemented because during data transmission, there are often cases where data loss or data damage occurs. To recover or detect the damage in the original data, we use Hamming code. In the next slide, we will look into some terms that are related to the working of Hamming code. The first one being redundant bits. These are the extra binary bits that are added explicitly to the original data bit to prevent damage to the transmitted data and also to recover the original data in case of a damage at the receiver end. In the next point, we will look into some formula related to redundant bits and how to add them in the Hamming code. The formula related to redundant bits is 2r more than equal to m plus r plus 1, where m refers to the data bits in the data and r refers to the redundant bits. Let's take an example. In case m is equal to 4, that means the data bits used are 4, we need to find the value of r. Using the above formula, let's deduce the value of redundant bits. 2r is more than equal to 4 plus r plus 1. 2 to the power r is more than equal to r plus 5. So using this, let's use r equal to 0. If we use that, we will get a value 1 that is more than equal to r plus 5, but that is wrong. Then using r equal to 3, that is 8 is more than equal to 8. This way we conclude that the Hamming code would be 7-bit data because the value of r is 3 and m is 4. Now let's move on to the next term related to Hamming code, that is parity bits. The parity bit is a method to append binary bits to secure that the total number of counts of 1 in the original data is either an even number or an odd number. Let's take a look, why do we exactly use parity bits? They are used to detect error in the original data which occurs during the transmission of data. Through this method, we can detect the error at the receiver end and also correct it. Let's take a look at different types of parity bits available. First one is even parity bit. In this case of parity type, the total number of ones counted is to be even in the count. In case the count is odd, then the value of parity is 1. Otherwise, the value should be 0. Similarly, the other parity bit is known as odd parity bit. For this parity bit, the total number of ones counted in the original data should be odd. If that is the case, the value of parity bit should be 0. And in case the value of ones in the original data comes out to be odd, then the parity value would be 1. Now let's move on to the next setting, that is the working example of the Hamming code. Let's take a look. Let's begin with the steps to be followed to solve a Hamming code issue. The first point being the position of the parity bit is determined using 2 to the power n term, where n represents the number series 0 to n. Assigning the position for parity bit using this method would be more clear during an example. For the second point we have the remaining positions represents the data bit. Now let's try using the value of parity bit for n is equal to 0. That means 2 to the power 0 is equal to 1. So all the bits with 1 in the last position are used to determine the value of the parity bit. To better understand the assignment value of parity bit, please focus on this mentioned table. In this table, we can take a look at the last position, that is n is equal to 0, and see the mentioned number. For P1, we can use a value 1 because n is equal to 0 and the last position value is 1. Then is number 3 because the last position bit is 1. Then similarly for number 5 because n is equal to 0 and the bit value is 1. So these three parity value can be used for n is equal to 0. Similarly, let's take a look when the n is equal to 1. That means 2 to the power 1 is equal to 2. So all the bits with 1 in the second position are used to determine the value of parity bit. Now let's take a look at the table to identify the numbers related to this parity bit value. The first one being 2 due to the presence of one bit in the second position. Then we have P3, presence of one bit in the second position. Similarly, the next would be number 6 due to the presence of one bit in the second position. Similarly, let's take a look at when n is equal to 2. That means 2 to the power 2 is equal to 4. So all the bits with 1 in the third position are used to determine the value of parity bit. And this would be 4, 5 and 6 number. Please read the points very carefully because next we will solve an example to better clarify all the concepts. Let's move on. The given example is the data bit to be transmitted is 1011 and we have to solve this using the Hamming code method. So the first step would be applying the Hamming code method and identify the given number of data bits. That would be 4 according to the question. So the number of parity bit would be 3 where the value would be 1, 2 and 4 according to the power of P expression. That means we will get something similar to this. This representation is in data bit format, where the first position is for P1 parity bit, the second for 2 to the power 1, that is 2 P2, and the third one is for 2 to the power 4, that is P4 parity. And let's put the value that is to be transmitted in the remaining positions. That would be P1, P2, 1, P4, 1, 0 and 1. Using this bit value, we will deduce the value of P1, P2 and P4 for data transmission. In this case, we are using even parity for the example. That means the number of ones should be even. Let's take a look. For P1 we have D1, D3, D5 and D7 as mentioned in the earlier slide. So the value would be P1, 1, 1 and 1 according to the data bits available to us by the question. That means the value would be 1 because the number of ones for P1 is odd. So to make it even, the value of P1 would be 1. Similarly, for P2 we have D2, D3, D6 and D7. Using the same method, we will get P2 1 0 1. So the number of ones for P2 is even. So the P2 value would be 0. Next is for P4. The value is D4, D5, D6 and D7, where P4 has 1, 0 and 1. That means the number of ones is even. So again P4 is equal to 0. Now using this, we get the new bit that is to be transmitted. That is 1010101. After transmission, in case, let's say at position 5, an error occurs and the value of 1 is converted to 0. To detect this error at the receiver side, we will use the Hamming code. To begin with, we will use the parity value to cross-check the original data bit. That means, let's do the parity bit method for this received data. So for P1 we have D1, D3, D5 and D7. So the number of ones is odd. That means the value of P1 should be 1 to make it even. Then for P2 we have D2, D3, D6 and D7. So the number of ones is even. That means the P2 value would be 0. Now let's move on for P4. That would be 4, D5, D6 and D7. Number of ones is 1. That means odd. So the value of P4 would be 1. Now let's take a look at the results that we obtained using this method. Foremost, this shows that the data transmitted is damaged and we can detect the error position using this method, that is, using the value of parity bits obtained, where this will lead to 2 to the power expression. That means 2 to the power 0 plus 0 plus 2 to the power 2. That means 5. That matches with the assumption we took. Now, to correct this error, we can use the position that we obtained, that is 5, and replace the 0th value with 1 bit. By doing this, we will obtain the original data. With this, we have completed all the topics to understand the Hamming code method. If you have any questions regarding the topic, you can ask them in the comment section. Thank you for watching.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.